Hi guys, this is your Unit 12 review video. I feel like it's been a while since I've made a video, so getting right back to it. The numbers I'm going to go through in the review sheet are listed right here. I ended up having to make a whole new document to do this video for you guys because obviously it wasn't already spread out. It was on one sheet front and back. So I went through and picked those problems. Additionally, I'll skip ahead for a second. I have some stuff at the end that if you're looking for additional trig proof practice, I do have another video that I made last year. It's called Trig Proofs Novak. I'll attach the link in the video, like in the description. These are the proofs that I go through in that video. So you can freeze this frame, copy them down in a notebook, try them, and then watch the video and make sure you got it. If you want a challenge, this is a pretty interesting one. So give that a whirl. I'll do that at the end of this video because this one is not in the Trig Novak or Trig Proofs Novak video. All right, so here we go. So starting right back at the top of the sheet, trig proofs are extremely different, or any trig identity stuff that we're doing in this unit are extremely difficult if you don't know your identities. So let's just take a second and go through the identities that you need to know and just write down at the top of your paper as soon as you get your test so that you can just keep referring back to them. The original Pythagorean theorem that we learned last year in Geo is sine squared of theta plus cosine squared of theta equals 1. Okay, that's the big guy. The other two are derived from the original equation. So like if I take this and I divide by cosine squared of theta, sine squared divided by cos squared is tangent squared. Okay, anything divided by itself is just going to be 1. And 1 divided by cosine squared is secant squared. If I take the original and then divide by sine squared, anything divided by itself is 1. Cosine divided by sine is cotangent. And then 1 divided by sine squared is cosecant. Okay, so those are your 3 Pythagorean identities to make sure you know. One thing I can kind of associate in my head here is that, well, obviously they can all be derived, but do you see how the C's match? 1 plus cotangent squared equals cosecant squared. So I don't know, something that I just kind of noticed that might help you memorize them, but you can always just derive it. Okay, then tangent is equal to sine over cosine. That's what we used to derive these guys. Cotangent is cosine over sine. And I always remember that because cotangent has cosine in the top. I like to associate letters. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So if you know these, you should be pretty good. Now, something else can come from these identities. Like I can rearrange these to be multiple things. So for example, I can solve this original trig identity for sine squared theta by rewriting it as 1 minus cosine squared theta. And that's a substitution we'll use sometimes. Likewise, I can solve for cosine squared of theta, and that's going to equal 1 minus sine squared of theta. And then I can do the exact same thing with the other 2 identities. So if you want, you could even take another second and rewrite those out for you, but I'll just do it for the original to give you the idea of that's what we're doing in some instances. It's just rearranging the identities so that our substitutions work the way we want them to. This is just a cute little cartoon I found on the internet. Protect yourself from identity theft. And if you look, he's got sine squared theta plus cosine squared theta equals 1. All right, anyway. Other things to know. Make sure you remember your ASTC chart. All students take classes. All your trig functions are positive in the first quadrant. Only sine is positive in the second quadrant. Only tangent in the third. And only cosine is positive in the fourth. Also remember how to convert to radians. 1 degree is pi over 180 radians. So for example, if you're going to convert 30 degrees to radians, you would multiply by pi over 180, and that's 30 divided by 180 is 1/6, so pi over 6 radians. So just something to think about that you'll have to do in some problems, depending upon the interval you're in. So think we're ready to go. So number 1, given 1 minus sine squared of theta minus sine squared of theta plus 1, my plus sign disappeared, and my theta for that matter. There we go. All right, that's problem 1. Solve for theta to the nearest tenth of a degree in the interval of 0 to 360. So we're in degrees. Okay, so let's start to just clean this up a little bit and combine like terms. So it looks like I have some sine squared of thetas that I can combine. So that is -3 sine squared of theta. I have then plus a sine of theta. And then 1 plus 1 is 2. Now, I can change these to x's, and I can also divide everything by -1. So let's actually change the x's first. Or change everything by -1, I should say. So -3x squared plus x plus 2 equals 0. I am not in love with the fact that the leading coefficient is negative. So let's just divide everything by -1. Beautiful. Now, does this factor? It actually does. I can guess and check this. There's only so many options I have for 3 and 2 as far as factors go. 3x and x gives you 3x squared. My only factors of 2 are 1 and 2, and my signs have to be different because it goes negative, negative. So this is actually plus 2 minus 1. The reason being, I get a negative 3x on the outside and a positive 2x on the inside, which sums to a negative x on the, or when I sum them together for my middle term. Okay, if you are not great at guess and checking, you still have your AC method, which I'll take a second here. And if you want to watch this, yay. If not, you can just skip ahead. AC method works like this, or your triangle method, sometimes we'll call it, where 3 times -2 is -6. And you're looking for factors of -6 that sum to -1. Oops, that's not what I wanted. So that first pair that I listed didn't sum to -1. But if I do a -3 and a positive 2, those sum to -1. So I split up the negative x in terms of -3x and positive 2x. And I do it in a very deliberate way so that I can factor out GCFs, because then it's factored by grouping. So I can pull out a 3x, I can pull out a 2. There's your common binomial. So 3x plus 2, that's the outside stuff, times x minus 1 is your factoring, which, oh hey, look at that, it matches what I did over on the left. So anyway, I'll erase this because I'm probably going to need some room. I have to then set each of these equal to 0 and solve. So x is equal to -2/3 and x is equal to 1. But it's not really x, it's sine of theta. I'm going to start with sine of theta equals 1. This is where your trig graphing skills come in. That's the graph of sine of theta. It is at a height of 1, or a y value of 1, at a certain degree. If this is one curve, this is 360 degrees, this is 90. So theta is 90. As far as -2/3 go, yeah, I have no idea. So that's where my calculator comes in. Pull my little Wabbit calculator over here. So what you're going to do is type in your calculator inverse sine of 2/3. And notice that I ignored the negative for right now. So second and second separations, 2 divided by 3. Yay. Okay. So 41.81, whatever. Okay. That's your reference angle, which is your angle in quadrant 1. Now, if sine is negative, that's where you think of your ASTC chart. Sine is positive in quadrants 1 and 2, so those are out. Therefore, you're looking for the angle in quadrants 3 and quadrant 4. So our quadrant 3 angle would be 180 plus that reference angle, whoopsies, 180 plus, can I go up and grab it? Oh man, my rabbit doesn't let me do that. Okay, so 41.803, whatever. Okay, so 221.8. That's the first one. Our quadrant 4 angle would have to be 360, take away the reference angle. So to the nearest tenth, 318.2. Okay, so all in all, your answers are 90, 221.8, and 318.2. So for number 6, we're looking in the interval of pi over 2 to pi, such that cosecant of x is 13 over 5. What is the value of cos of x? There's actually 2 ways to do this problem. The first way is using the identities. If I have cosecant and I'm looking for cosine, I can use the identity sine squared of theta plus cosine squared of theta equals 1. Now you're probably thinking, all right, but I don't have sine. You're right, they don't come out and tell me I have sine, but they do give me the reciprocal of sine. So therefore, sine of x is equal to 5 over 13. Now I just have to plug into the identity. So 5 over 13 squared plus cosine squared of theta is equal to 1. And then we just solve. So this is 25 over 169. Then I may change this to 169 over 169. Subtract 25. So cosine squared of theta is equal to 144 over 169, which you should recognize both of those as perfect squares. So when you take the square root, we have cosine of theta is equal to plus or minus 12 over 13. Now, plus or minus, because now we have to determine, is it going to be positive or negative depending upon the quadrant you're in. So if we're between what would be 90 and 180, 90's here, 180's here, that means we're looking in quadrant 2. If all students take classes, only sine is positive in the second quadrant. Therefore, cosine of theta is negative 12 over 13. So that's using the identities. Now, technically, it didn't tell me I had to use the identities. So if this was a test question and I don't want to use the identities, we can just draw a triangle in quadrant 3. So here's your triangle in quadrant 2. If sine of x would be 5 over 13, that's opposite over hypotenuse. Using the Pythagorean theorem, I can solve for this missing leg, which would end up being 12. This is also a 5, 12, 13 Pythagorean triple, which some of you may recognize. So then if I want cosine, that's adjacent over hypotenuse, or 12 over 13. But since cosine's in the second quadrant, or since the angle's in the second quadrant, cosine's going to be negative. So I end up with the same exact result. Technically, that's a negative 12. You're going to the left 12. All right, so now for number 9, we're going to solve in the interval of 0 to 2 pi. Notice it's in radians, so my final answer should be in radians. Solve for cosine. So I'll add over the 3, and then divide by 4. When I take the square root, I get cosine of theta is equal to positive and negative radical 3 over 2. Now, if you don't know this angle off the top of your head, you could use your calculator. So I could do inverse cos of radical 3 divided by 2 and get 30. Or just know cosine of what angle gives you radical 3 over 2? 30. Okay, now positive or negative, because we took the square root of a square, so we have 2 solutions here. Therefore, we have an angle in every single quadrant. Our quadrant 1 angle would be 30. Our quadrant 2 angle, if our reference angle here is 30, would be 180 take away 30, which would be 150. 180 plus 30 would give me the angle in quadrant 3, so that's 210. And then lastly, if we're over here in quadrant 4, it would be 330, or 360, take away 30, which is 330 degrees. So our final answers are 30, 150, 210, and 330. And I said final answers by accident. Okay, those are my degree answers. I need my radian answers. Therefore, I have to multiply everything by pi over 180 and reduce. Okay, so here we go. 30 times pi over 180 would give me 1 over 6 pi, or pi over 6. If I'm going to reduce 150, and maybe you're not as quick at reducing, in your calculator you can do 150 divided by 180, and then do a math frac. So 5 over 6, so therefore 5 pi over 6. And then you just do the same process for 210 and 330. Oops, that looks nasty. Okay, so 210 goes to 7 pi over 6, and 330 goes to 11 pi over 6. These are then your final answers. Now on your test, you're going to have to prove some identities. So in number 12, you're going to prove, in this case, I would say the left side equals the right. Start with the more complicated side. Remember, you're not touching the other side. You're only working on one side. So I'm noticing a couple things here. I have tangent. That can be rewritten in terms of sines and cosines. Same thing with cosecant squared. So something I'm thinking about. Now 1 plus tangent squared of x looks like one of my identities. So if I scroll back up, it's secant squared. And secant can be rewritten in terms of cosine. So let's just start making some substitutions here and see if anything happens. So sine of x, or tangent of x, is sine of x over cos of x, times 1 over sine squared of x. Make sure you don't drop off that squared. Completely divided by, we just said 1 plus tangent squared of x is secant squared of x. Now right here what I'm noticing is I can cancel a sine in the top with a sine in the bottom. That's 1 over cosine of x, sine of x. Completely divided by, now I'm thinking I'm going to rewrite this as 1 over cosine squared of x, because secant is the reciprocal of cosine. Okay, make sure again you don't drop off your squares. Now, some of you may have noticed right away that 1 plus tangent squared is secant squared and then jump to rewriting it. Don't do that. It's a proof. Make sure you're showing each of your steps. Now, if it wants you to divide fractions, divide the fractions. So I'm going to erase this so I have some more room here. So I'm going to write this as 1 over cos of x, sine of x, times the reciprocal, which is cosine squared of x over sine of x. What am I doing? Cosine squared of x over 1. Keep, change, flip. Okay, and then I notice some more stuff cancels. I can cancel 1 cosine in the numerator with 1 in the denominator. So when I multiply across, make sure you're not cross multiplying here, I get cosine of x over sine of x, which cosine of x over sine of x is cotangent of x. And then we're done. We did it. Notice I never touched the right-hand side. I strictly worked the left side here, or I mean it could be the right, it's really depending upon what's the more complicated side. I worked one side and showed how I got from really A to B by just showing these manipulations. Okay, to the nearest minute, the values of theta in 0 to 360 that satisfy the equation secant squared of theta plus tangent of theta equals 7. Now, right away, I'm noticing that I have trig functions that don't match. Okay, I got secant and tangent. So I gotta think, is there a way I can rewrite secant squared, because I mean it's squared, it's probably an identity, so that it's in terms of tangent. So again, if I scroll back up, look at your identities. Secant squared of theta is tangent squared of theta plus 1. So that's what I'll sub back in. So now everything's in terms of tangent. So that's great. Let's rearrange this a little bit. So this would be tangent squared of theta plus tangent of theta. And if I subtract 7, that would be minus 6. Now, just like what we did before, it may be good for you just to think about this in terms of x's. Do that substitution. And then think, does this factor? Factors of negative 6 that sum to 1? Yes, it does. So we get x equals negative 3 and x equals 2. Okay, but it's not really x, it's tangent. I'm going to relocate this because I'm running out of room. Okay, so we're up here, right? In my calculator. Move this up a little bit. Okay, in my calculator, I'm going to do inverse tan of 3. And I get 71.56. Okay, that's your reference angle. Tangent is negative though. So if we think of all students take classes, we're not going to look in 1 and 3, we're going to look in 2 and 4. So quadrant 2 theta, quadrant 4 theta. Okay, now something else to notice is your directions say nearest minute, so make sure we do DMS in our calculators. Okay, so here we go. So quadrant 2 theta would be 180, take away the 71.56 number, which actually, can I just store this real quick? I'm going to store that number as x, just to make my life a little easy here. Okay, so 180 take away the reference angle. So 251.56. However, I need to make sure I convert that, and I just realized I did plus x. That would be quadrant 3. Never mind. So 180, take away the reference angle. There we go, 108. Now we're going to convert this using DMS. So second apps, option 4. Okay, so 108 and 26 minutes. This is only 5 seconds, so we're not going to round up. Okay, quadrant 4, I need 360, take away the reference angle, and then I'll convert that using second apps, option 4. So 288.26. Again, not enough seconds to round up. You need 30 seconds to round up. Okay, and then we'll do the same exact process over here for tangent of theta equals 2. Now, second tan of 2, so 63.43. Okay, but we're going to use that to get into quadrants where tangent's positive. So now we actually will refer to 1 and 3. So this would be my angle in quadrant 1, so let's just convert it. So 63 degrees, 26 minutes. And then for quadrant 3, I'll do 180 plus that angle. And then just use apps, DMS. So 243.26. Kind of squeezing it in here on my screen. All right, and there you go. So these are your answers. Okay, solve for all values of theta, or all values of x, I should say, where x is between 0 and 360 for radical 3 cosecant of x minus 2 equals 0. So when I see the cosecant, I'm thinking to myself, can I turn that into sine to make my life a little bit easier? Which I will eventually. So let's first solve this for cosecant. So I'll add over the 2 and divide by radical 3. But let's think in terms of sine. So I'll take the reciprocal. Now, sine of what angle gives you radical 3 over 2? That's 60. Now, because sine is positive, you're only going to look in quadrants 1 and 2. So your quadrant 1 angle is 60, and your quadrant 2 angle would be 180 take away 60, which is 120. And then you're done. Okay, solve now in the interval of 0 to 2 pi. Okay, so keep in mind, radian answers in the end. Let's clean up the parentheses. And solve for secant. Okay, so secant of theta divided by 3 then, I get secant of theta equals 2. The reciprocal of secant is cosine. So that's 1 over 2. Cosine of what angle gives you 1/2? That would be cosine of 60. Because cosine is positive, you're only going to look in quadrants 1 and quadrant 4. Because all students take classes. So our quadrant 1 angle is 60, our quadrant 4 angle is 360, take away 60, which is 300. But then it wants your answers in terms of radians. So just make sure then you multiply by pi over 180. And then reduce. 60 over 180 is 1/3. And then 300 divided by 180 is 5 pi over 3. And those are your answers. All right, here we are. We got another proof to do. I've got cotangent of theta times sine squared of theta, yada, 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 equals sine of theta. Okay. I'm noticing I have some identity stuff in here. 1 minus sine squared of theta. I also notice I have a cotangent. I can rewrite that in terms of sines and cosines. I can also rewrite that in terms of cosine. So let's just start putting some substitutions in. Cotangent of theta is cosine of theta over sine of theta. Okay, then times, I'll leave this in terms of sine, because then some stuff will cancel. All over. Now if we look back up at our identities, sorry, wrong way. 1 minus sine squared of theta is cosine squared of theta, all from that first identity that we worked with. So I'm going to rewrite 1 minus sine squared of theta as cosine squared of theta. And then secant I'll write as 1 over cosine. By doing this, a lot of stuff will cancel. Okay, I have a sign in the bottom that will cancel with a sign in the top. So my numerator really goes to cos of theta, sine of theta. Maybe I'll leave this as over 1 for right now. Down here, I have a cosine cancel with another cosine. So when I multiply across, that just gives me cosine. Okay, so really I just have cos of theta, sine of theta, divided by cos of theta. Oh, hey, look at that. Cosines drop out. Sine of theta. We did it. Okay, solve for theta to the nearest degree in the interval of 0 to 360. And we've got cosecant squared and cotangent. So just like our other problem, our functions aren't matching. So we should look at our identities to see can we substitute anything in for cosecant squared, which we can, and then see if it will match cotangent. We go back up to our identities. Cosecant squared theta is 1 plus cotangent squared of theta. So I'm going to make that substitution. Okay, so now we're going to just clean this up a little bit. And change it to x's. Factors of negative 54 that sum to negative 3 are negative 9 and 6. So x equals 9, x equals negative 6. But it's not really x, it's going to be cotangent. We don't have a cotangent button or know how to work really much with cotangent, so we're going to change it to tangent by taking the reciprocal. Okay, so then by doing this, I just have to use my calculator. So I'm going to do inverse tan of 1/9. Okay, so I get 6.34. Tangent's positive, so I'm going to want the quadrant 1 angle, so it looks like to the nearest degree is 6 degrees. I'll also want the quadrant 3 angle, because then tangent's going to be positive there too, because of all students take classes. So 180 plus 6.34, and then I'll round to the nearest degree, so 186 degrees. Okay, and then we do the same thing for inverse tan of 1/6, but then tangent's negative, so you're going to look in quadrant 2 and quadrant 4. All right, so solve for theta again to the nearest minute. So there's your intro for DMS in the interval of 0 to 360. You have a fraction here, so let's just make it not be a fraction. So I could cross multiply and end up with sine squared of theta is equal to 3 minus 4 cos of theta. I don't like that my trig functions don't match, so I can sub in for sine squared of theta 1 minus cosine squared of theta. I'll clean it up a little bit so that we have it all set equal to 0. And actually I'll change this to x's too. Okay, I'm not in love with the negative coefficient here, so I'll add the x squared over. So I need factors of 2 that sum to negative 4. Yeah, that's not happening, right? So we can't factor that. Therefore, we need to use our quadratic formula. Okay, so when we solve, we got negative b, which is 4, plus or minus the square root of b squared, so 16 minus 4ac, all over 2a. Okay, so this would be 4 minus 8, which is radical 8 then, all over 2. Now what I'm going to do then is write this in terms of cosine again. So cosine of theta is equal to 4 plus radical 8 over 2, and cos of theta is equal to 4 minus radical 8 over 2. I don't take my time simplifying this. This is not a final answer. I really only care about what its decimal value end up being, so I can find the angle. Okay, so in my calculator, 4 plus radical 8, take that, divide it by 2, I get 3.41. Okay, but without even doing second cos of this, I know I'm not going to get an answer. I'm going to reject this. And just to show you, second cos of that answer. Yeah, error. Okay, now the reason there is an error is because if you look at the graph of cosine, it's always oscillating between 1 and negative 1. It's never going to do it all of a sudden and like jump up and hit 3. That's just not going to happen. So what the inverse function does is it says, at what angle is cosine going to be at a y value of 3.41, and it just doesn't happen. So that's why you're getting a rejection there. 3.141 is outside of the range of cosine, so that's why an angle doesn't exist. Let's see what happens on the other side though. So 4 minus radical 8 divided by 2. Okay, that looks like a number I can work with, 0.5857. Okay, so I'll do second cos of that answer, so 54.14, but we're going to want it to the nearest minute, right? So if cosine's positive, we're going to look in quadrant 1, so that's this reference angle, so second apps, option 4, so 54 degrees, 8 minutes. And then we're also going to look in quadrant 4. So that would be 360, take away our reference angle, and then convert it. So 305 degrees, 52 minutes, because this is going to round up. It's more than 30 seconds, or 30 seconds or greater, I should say. And there are 2 answers. All right, last one on the sheet is just a proof. Prove tangent of x times secant of x is equal to sine x over 1 minus sine squared of x. I'm going to start on this side, just because I know I can rewrite a bunch of stuff. Tangent is sine over cosine. Secant is 1 over cosine. Now when I multiply, remember when you multiply fractions, you multiply across, not cross multiply. I get sine of x over cosine squared of x. Cosine squared of x is the same thing as 1 minus sine squared of x, which, oh hey, look at that, they match. And we're done. So going to the bottom here, these are the proofs I was talking about are in the other video. I'm going to go through this one now. Something I notice is that this can be rewritten in terms of cosine. I can write that as 1 minus cosine squared of x all over 1 minus cos of x. I still have the 1 minus hanging out of here. 1 minus cosine squared of x, that's a difference of 2 perfect squares. I can actually factor that. 1 minus cos of x is cancel, so this leaves me with 1 minus 1 plus cos of x. Distribute the negative. 1 minus 1 is 0, and that gives me negative cos of x. There is another way to do it. I actually did it the harder way the first time I looked at this proof. I changed this to 1 minus cos of x over 1 minus cos of x, and actually subtracted the fractions. It will work. It takes a little bit longer though. So I'm curious what everybody else thought of if they tried this one. All right, so good luck studying.